Hello, and welcome to Food Safety Fridays. My name's Simon Timperley from the International Food Safety and Quality Network. Today, the topic is best practices in CCP documentation. And our guest presenters today are, well, we've got three today, bonus. So we've got Ian Scott-Mance, who's the Digitalization Project Manager at Mettler Toledo. We've got Vic Kelly, ProdX Technical Support Specialist at Mettler Toledo, and of course Rob Rogers, who's Director of Compliance Advancements in our initiatives. I'm sure many of you know Rob from lots of webinars he's done with IFSQN. So welcome everybody. Should we do the customary and where are we joining from today? Where are you joining us from, Rob?
I'm in Tampa, Florida.
Is it sunny?
Oh, it's beautiful here today. I mean, beautifully sunny. It's probably about 85 degrees right now.
Very nice. And I don't know, are you there, Ian?
Yes, I'm here. Can you see me?
I can't, but can hear you.
On my screen, it's saying starting event. This might take 15 seconds with... I've got dots going across, but I'm just outside Cambridge anyway, in the UK.
Right, just outside Cambridge, got that. And Vic, where are you joining us from today?
I'm in Spring Hill, Florida. It's about 30 miles north of Tampa.
So you're neighbours with Rob, that's lovely. Okay, tell us where you're joining from in the sidebar. Oh, Frank from sunny New Jersey, Susan from Iowa, Raheem from Nigeria, Kristen, Minnesota, Nitiki from Canada, sorry, forgot your name wrong, Michael from Zimbabwe, Arinjit from India, Breku from Romania. Look, all over the world, and it's great to have you all. You're all very welcome. Food Safety Fridays is sponsored. Bring you these free webinars each week, and one of the kind sponsors is Mettler Toledo. So we're going to play the sponsors ads now, and then we'll play the presentation. Okay? Be back in a few minutes. Okay, I'll be back for the Q&A later.
Welcome to our presentation on best practices in critical control point documentation, how to meet compliance standards, enhance food safety, and streamline your documentation processes. So let's get right on with it. Just a quick reminder about the speakers today. First up is Rob Rogers, the Director of Compliance Advancements for R&R Initiatives. He brings 20 years of expertise as a food safety professional. Joining him is Vic Kelly, our ProdX Technical Support Specialist, who will be delivering a live demonstration on how ProdX exemplifies best practices. Finally, it's me. I'm Ian Scott-Mance. I'll be starting with some key fundamentals on our topic, with a special focus on digital documentation and record keeping. We're excited to have this opportunity to share our insights with you. We will start by discussing why best practices are relative and can vary based on context and individual site adaptations, depending on your specific needs. Next, we'll have a look at why critical control point documentation and records matter, HACCP, and monitoring routines. This will provide context and scope to parts of this presentation around standards, legislation and regulations, which will be presented by Rob Rogers. We'll then explore how digitalisation and artificial intelligence are becoming irresistible forces, shaping how we manage documentation and record keeping. Vic will then provide a practical demonstration on how transitioning to digital and automated record keeping can save you time and money, while maintaining the highest levels of data security. Finally, we'll wrap up with a Q&A session. We look forward to an engaging and insightful session. Please feel free to post any questions at any time in the Q&A area during the presentation. So now let's get started. When we think about documentation, it's easy to assume that there's a universally accepted way to do things. However, the reality is much more complex. There is a well-known saying in the UK, what's good for the goose isn't always good for the gander, meaning that what works for one may not work for another. Each customer we encounter has unique needs, challenges and circumstances. Some sites may use completely manual data collection processes, some use automated digital collection, and others employ cutting-edge AI applications. This highlights why we can't adopt a one-size-fits-all approach to documentation. So by recognising these differences, we can better serve you by providing documentation and record-keeping best practice solutions that fully support your needs. Food business operators must establish documentation and record-keeping procedures to implement and maintain food safety systems. There are specific requirements for this, which we will cover later in the presentation. But before we can go any further, we need to clarify a few points to avoid any confusion. A document is a piece of information that serves as a reliable reference point and must be maintained to ensure validity. Documents should be reviewed periodically or when modifications occur and revised to reflect any changes. For example, documenting the HACCP or root cause analysis processes is essential. A record, whilst also a document, permanently captures information about activities or observations that have occurred. These records must be accurate and legible. Examples of records include monitoring activities, validation, verification, and review activities. With the advent of digitalization and AI, the increasing use of these documents and records is helping predict where and when contamination events may occur, allowing proactive prevention measures to be implemented. But more on this later. As we're focusing on CCPs, HACCP is a good starting point. This is just a very simplified take on the subject, with an emphasis on the parts relevant for this presentation. For every part of the production or supply chain, we see it on the left there is a contamination risk that needs to be assessed. Today, we're going to focus on the packaging area. In most cases, a final quality and contamination detection step is included at the end of the line, generally where you would find a CCP. The HACCP process will define the potential hazards and the risk mitigation elements that need to be implemented, such as which device to use, monitoring frequency, operator training, and service requirements. Full documentation and records of these CCPs must be maintained to provide proof of due diligence and ensure that your critical controls are operational and fit for purpose throughout their life cycle. And here, once again, AI rears its head, consuming the data to create positive feedback loops, reducing further risk. For an AI application to be effective, it needs accurate data from timely documentation and record-keeping processes. Moving swiftly on, root cause analysis, or RCA. As I'm sure you are aware that this is a systematic process used to identify the underlying causes of food safety issues, ensuring that the organisations that you work in can effectively address and prevent reoccurrences. Documenting the RCA process is crucial as it provides a clear record of the investigation and outlines the preventative measures implemented. It's a validation of effectiveness in mitigating future risks. However, identifying the true root cause can sometimes be quite challenging, especially when the issue is deeply embedded within the supply chain, potentially obscured by multiple contributing factors. Advancements in AI are transforming the analysis of RCA data, enabling companies to detect patterns and predict potential food safety risks much more accurately. By leveraging this data in AI applications, organizations can proactively address vulnerabilities in the supply chain, ultimately preventing food safety events before they even occur. So before I hand over to Rob, I want to clarify some terminology. There are numerous instances in publications where these terms are sometimes used interchangeably. For the purposes of best practice, we should define these terms now. Routine monitoring, the regular and systematic observation of critical control points during food processing to confirm they remain within established safety parameters. This involves ongoing checks and documentation of critical limits. Performance verification, the process of evaluating whether the monitoring activities for critical control points are effectively preventing hazards. This includes reviewing monitoring records and conducting testing to verify food safety measures are being implemented properly and sensors function as intended. Performance validation. This is a scientific process of confirming that the control measures in place can consistently achieve the intended food safety outcomes. This involves rigorous testing to assess the effectiveness of CCPs in controlling the identified hazards and ensuring that the implemented processes align with regulatory standards and best practice. Over many years, Rob Rogers' insights have been instrumental in shaping best practices around risk mitigation documentation processes for hundreds of food manufacturers worldwide. Today, he will discuss the critical expectations surrounding documentation in food safety, exploring how effective practices can not only fulfill regulatory requirements, but also contribute to overall quality and transparency within the supply chain. So, over to you, Rob.
Thank you, Ian. Let's take a moment to explore the global compliance landscape when it comes to food safety. The image here highlights the geographic reach of both local regulations and internationally recognized food safety programs that many manufacturers must navigate today. Looking at the regional regulatory requirements, each country has its own specific set of regulations that manufacturers must adhere to. For example, in the U.S., the FDA enforces the Food Safety Modernization Act, while in Canada, the Canadian Food Inspection Agency holds companies accountable under the Safe Foods for Canadians Act. In the UK, it's the Food Standards Agency that sets the standards for food safety and quality. On the global stage, manufacturers may also need to align with internationally recognized food safety programs, such as those found in the Global Food Safety Initiative or GFSI programs. These programs, like SQF, BRCGS, IFS, and FSSC 22000, provide framework for managing food safety risks and ensuring compliance across borders. Many manufacturers face not just regulatory requirements, but also the expectations of direct customer or corporate mandates, which can further complicate this compliance landscape. Now, while the specifics may differ, all of these regulations and programs share a common goal. They expect manufacturers to identify, monitor, and control the risks that are critical to food safety. These risks are often tied directly to critical control points or preventive controls, key areas where failure can lead to contamination, non-compliance, and serious repercussions. Ian provided a brief look into the hazard analysis, and that's a good place to highlight similarities in the regulations. Under the Food Safety Modernization Act, specifically the Preventive Controls for Human Food Rule, the FDA requires food manufacturers to conduct a hazard analysis to identify and evaluate all known or reasonably foreseeable hazards. This includes physical hazards like foreign material, which are critical to address through preventive controls. As for Canada, the Safe Foods for Canadian regulations play a similar role, where businesses are expected to conduct a hazard identification and analysis to recognize all potential biological, chemical, and physical hazards. This ensures that companies address all risk factors that could compromise food safety before they reach the consumer. In the European Union, the requirement mandates that food business operators implement HACCP, or Hazard Analysis and Critical Control Points. This regulation focuses on identifying, evaluating, and controlling all food safety hazards, including labeling errors and physical contaminants like metal and glass. Although the language and specific requirements differ, the underlying principle in all of these regions is consistent. On this slide, we're looking at the essential elements of validation, verification, and monitoring, which are common requirements across the various regions. These processes ensure that food safety controls are effective and consistently implemented. Validation is required to ensure that the controls, the measures you put in place to manage food safety hazards, are actually capable of controlling the identified risks. Verification, which includes activities like the calibration of process monitoring instruments and regular review of records, ensures that preventive controls are being implemented consistently and that they are working as intended. Monitoring, which is an ongoing activity that requires facilities to continuously track the performance of the controls, including how frequently it's monitored and which personnel are responsible for the task. Notice that these records must be maintained for a period of time to show long-term data. Now let's take a closer look at the GFSI recognized food safety standards. These programs are widely used by manufacturers across the globe to ensure the highest food safety standards, and they all emphasize the importance of validation and verification of food safety controls. The BRCGS program places significant emphasis on documented validation of control measures. This means you must show that the preventive controls in place are effective at mitigating the food safety risks. As for verification in SQF, facilities must document a variety of activities. This includes verifying the monitoring of the CCPs and other food safety controls. FSSC 22000 requires monitoring, including internal audits, and the analysis of results to verify that food safety systems are functioning as it should. Regular audits are conducted to assess compliance, and any discrepancies must be corrected promptly to maintain food safety standards. So as you can see, all three of these GFSI recognized programs highlight the critical need of thorough validation and verification processes. These programs require manufacturers to document their food safety controls, regularly verify that those controls are working, and ensure ongoing compliance with global food safety standards. The key takeaway here is that a strong validation, verification, and monitoring system provides transparency, consistency, and confidence in the food safety processes, helping companies avoid potential risks such as contamination or non-compliance. Now let's dive into the critical role that documentation and record keeping play in ensuring food safety compliance. Across the various global regulations and standards, documentation is a key component for proving that a food facility is in compliance with the food safety requirements. In the U.S., under the Food Safety Modernization Act, it's required that food manufacturers maintain records for at least 2 years. This includes documentation for hazard analysis, preventive controls, and records for calibrations and inspections. In Canada, The Safe Foods for Canadian regulations require businesses to also maintain food records for at least 2 years. This is critical for both self-audit and monitoring records. In the European Union, businesses are required to maintain detailed records for at least 24 months or 12 months past the expiration date. This includes records of critical control points, monitoring activities, and corrective actions. For the GFSI recognized programs, documentation is a cornerstone. Each of the programs mandates validation and verification documentation to show that the control measures put in place are effective. Without proper documentation, manufacturers are exposed to risks such as regulatory penalties, audit failures, and product recalls. Maintaining accurate, consistent records not only ensures compliance with global standards, but also provides a clear audit trail that can protect the business in the event of a food safety issue. What happens when things go wrong? Let's look at 3 real-world incidences from across the US, Canada, and the UK where food companies face serious consequences. Not necessarily due to the equipment failing, but because they couldn't prove it was working correctly, or worse, they falsified documentation. In the US, a food manufacturer received an FDA warning letter after it was discovered their metal detectors logs had been falsified. Investigators found inconsistencies in the timing of test entries, and surveillance footage revealed the test hadn't actually been performed as recorded. This underscores that documentation must not only exist, but it must reflect actual verifiable activities. In Canada, a mid-sized bakery failed an audit due to an incomplete documentation of their inline checkware. Though the equipment was calibrated, the company could not produce consistent records showing the verification checks were done as required. The lack of documentation meant they couldn't prove compliance with net quality regulations. And in the UK, a ready meal processor issued a nationwide recall after consumers reported it found glass fragments in their product. Upon investigation, the company couldn't provide documentation proving their X-ray system had been validated or regularly verified. Despite having the equipment in place, the absence of proof meant they couldn't demonstrate due diligence or compliance. These cases clearly show that having inspections systems in place isn't enough. Regulators expect companies to prove these systems are being used correctly and consistently. Without proper documentation, validation, verification, and monitoring logs, your compliance efforts can unravel very, very quickly. There are also plenty of examples for issues related to manual documentation. In the United States, the FDA issued a warning letter to a ready-to-eat bakery manufacturer after discovering significant violations of the food safety regulations. These included failure to properly monitor and verify critical control points, a lack of documentation proving the company was in compliance with the FSMA Preventive Controls Rule. In Canada, the CFIA makes it very clear. If a company's self-audit records, especially those that are maintained manually, don't reflect actual operations or are inconsistent, that alone can result in an audit failure. These failures can lead to enforcement actions or product withdrawals. So even if a process is working, if it's not documented properly, it's considered non-compliant. In the UK, a cereal manufacturer faced legal actions after consumers found a sharp piece of metal. Although the company had responded by stopping the line and using X-ray systems to check the products, the investigation revealed that their handwritten documentation didn't accurately track the affected batches. This documentation gap allowed contaminated products to leave the facility and reach the consumers, demonstrating that incomplete or unreliable paper records can directly contribute to food safety risks and legal liabilities. Clearly, maintaining documentation manually might seem easy and inexpensive, but it introduces significant risks. Human error, falsified logs, missed records, these are all too common, and regulators are cracking down. Let's talk about a foundational shift that's transforming food safety management, moving from manual, paper-based documentation to digital systems. For decades, food safety records have been kept in notebooks, clipboards, or binders, and we've just shown real-world examples where these manual processes are filled with problems. Companies failing audits or receiving warning letters, not necessarily because their process failed, but because their records didn't prove they were doing what they said. Digital documentation helps to eliminate these gaps. It provides real-time logging of inspection activities, automatic timestamping, and user-specific traceability. If a critical control point fails, a digital system can alert you instantly and prevent further production until a corrective action can be taken. You can link inspection data directly to batches, products, and time periods. No lost pages, no unreadable handwriting, no guesswork during a recall. And from an audit standpoint, it's a game changer. Having digital records mean you can pull up everything instantly. You can even run trend reports to show how you're proactively improving the process over time. This helps to strengthen your audit score and demonstrates a commitment to continuous improvement. Digital also boosts internal accountability. You know exactly who performed each check, when, and what the results were. If something's missed, you don't have to spend hours investigating. You have a complete, searchable audit trail. Ultimately, moving to digital is about more than compliance. It's about building a more resilient and responsive food safety culture. It frees up your team to focus on proactive food safety management rather than just data entry. It helps you sleep better knowing that if a regulator, a retailer, or a consumer asks you for proof, you've got it at your fingertips. For more on this, I'll hand it back over to Ian.
Thank you very much, Rob, for your insights into the regulation requirements. Just to finish off the subject of moving to digital, I'd like to say a few more words before then handing over to Vic. One of the key advantages of digitalization is the automation of data collection. By automating these tasks, you reduce the time spent on data entry and also reduce the risk of manual input errors. In addition, reporting becomes quicker and more accurate, as well as opening the opportunity for new insights in near real time. Audits can be streamlined to reduce the stress associated with these reviews. And ultimately, automating data processes translates into much more efficient workflows, allowing your team to focus on those more higher value activities and driving better business outcomes. So before I finish, I'd just like to say a few words on how anonymized data sharing of food relevant data and events is starting to revolutionize how risk is assessed. There are initiatives happening now with many companies sharing anonymized data across their entire supply chains. This collective data is fed into AI to analyze patterns and predict risks to build a common global risk map. This predictive analysis also enables them to identify root causes of contamination. By understanding these underlying factors, they've started to introduce robust documentation and data collection practices that not only reflect their compliance needs, but also enhance their risk prevention strategies. Let me now hand over to Vic to start the demonstration of ProdX. This tool embodies the best practices we've discussed, streamlining food safety documentation and data collection. We're going to move over to Teams, where Vic will be able to share his screen and we'll be able to then demonstrate the software. So hold on tight and let's move over there now. Hi, we're now in Teams. Vic, I can see you there smiling. So how are you?
Good, good. Thanks for letting me join in the conversation, Ian. I'll give a brief overview. Is that what we're looking for?
No, so what we want to actually do here, we had this discussion earlier on today, that it's such a big software package, and the demonstration could last for hours if we wanted to show everything. But in conversations that we have with our customers, there's always sort of like 5 things that come up all the time. So what I'd like to do is if I could prompt you through those 5 things, we could sort of discuss them, go through them, explain them. And then at the end, of course, anyone that's listening to this presentation will have the opportunity to ask anything else in much more detail. So that's the way we can work on that. I'm going to turn my camera off now so that you don't have to see my face anymore. And then we'll move over and we'll go with the question 1, which is pretty much the $64,000 question, is can you give me a brief overview of what the software can actually do?
Okay, well, great. So we're looking at my screen. This is the top level of the monitor where we're monitoring the equipment that's on the line, and we can see the real-time status of the systems. We can see when they start and stop, or when there's an alarm, and the line comes back online, that kind of thing. We can drill down to a line level, which gives us a little bit more information of what's been going on. We're seeing past production that's been taking place over the last several hours. We can also see the OEE for a specific piece of equipment from here. So this is just giving us a top level of view of what's going on the production line. We can go down and drill down to the device level, and here we're seeing even more information. We see our same production data for the last several hours, but we also see the counters and statistics, and there's 2 displays being shown here. There's the total since the beginning of the run, and then there's the hourly information that's also being displayed there, as well as the OEE, and it breaks it down into different things. We can see when the PVRs have been done, or if they failed, or that kind of thing. And so that information is at the top level, easy to be seen. This information is being updated about once every minute, so it's nearly real time. We can look at events and rejects that are going on, and we can set up views that show certain things. For example, we can look at a performance verification, and so we can see that actually come in automatically into the system when it's completed. Sometimes during a performance test, it may fail, and so when we look at the rejects, we can see here that the rejects are here, and we can actually document what we found when there was contamination or such. If we go in and look at the reject, we can actually see additional information. What was the mass? We're looking at an X-ray here. And what was the mass of the item that was detected? We can see the reject image. So we've got our contaminants represented here in the image. But we can also go in and see through the corrective action, preventive action, the CAPA, and it's possible to have a customized drop-down list. So we're just going to choose a reason, and we'll choose what we did for that. When we save that, that's going to document the time date that initial remark was made. Frequently, there may be a quality manager may come behind and come in to verify the information, and the text boxes below are free input. You can type what you want there. That further documents what was found in the contaminant. And when that's saved, we get another time date stamp with who modified it. And this is going to be last modified. So as you may investigate what the cause of the contamination was, you can document that, and that becomes a permanent part of that record. So it shows that you were doing your PVRs. When it failed, you came in, you figured out why it failed, you corrected it, and that has now documented that. So that becomes useful in the event of an audit when you go through your periodic audits through the year. Aside from that, we can look at sorry, Ian.
No. So carry on, Vic.
Okay. So that's what we can get with the rejects. If we go back, we can look then at again inspection results and charts. We can go back here. If we hover over these points, we can see. So we can just, this is a top level view. All of this information can be reported and sent. So, Ian, I think what's your next question?
Okay, yeah, that's it. That was I think everyone can understand now the depth that the software goes in. Brief overview. So, what I'd like to do is maybe dig a little bit deeper in the one thing, especially on the data, especially because this is about documenting CCPs. So, can you give some other specific examples of how ProdX helps document certain things, and am I able to see exactly everything that happened yesterday or historical events? How far can I go back? And leads into the question is sort of like, how long does ProdX actually retain all of this information that I'm documenting?
Okay, so let me start with that one first. ProdX will retain this data. It's managed by a utility where archives can be created. So the end users are actually in control as to how long data is retained or not. It's not an automated process to actually back up or archive. So it doesn't eliminate any data that's been collected. It's stored in the database and stored indefinitely and will be managed by the end user. So they would have control over data that's retained. And frequently what will happen is they will create periodic archives, which is a static database, not having any new data added. And many customers have to retain the information for 2 years. And at the end of 2 years, they'll just delete a static database, one of the archives. In that way, they're managing, they've got the data available. It can be reported on it, just like it's a live database that's having new data entered.
And one point on that. Okay, so we're keeping the data for as long as the customer wants the data, so there's no restrictions there. But what about the security of this data?
It's an SQL database, and it's not something that a normal user has access to. To go in, the data can't be edited in the database by users. So from that perspective, it's going direct from the device to the database. I don't have to come back, other than documenting the kappa. I don't have to come back and do anything to retain the data. It's just automatically taking place. So the rejects and the PVRs are being captured. It's all going into the database automatically without user input.
So what you're saying is you need IT admin authority to get anywhere near that data. Once it's in, it's stored and it's there for good.
Yes, that's correct. So typically a database administrator would be the only one that has access to get into the database.
Okay, great. Thank you. Next question, and I think you've already touched on this briefly already, is how are corrective actions and incidents at your critical control point managed and documented in ProdX? So I think just to recap on what you said before, because it's a really important part of what this does.
Yeah, so we're capturing when the performance test is done, that automatically comes in to the database, and so they can come in and they can document again the kappa of what takes place here, edit that item, and use the drop down box to document that and such. So this can be automated in a report and sent out as needed. So one other thing that we haven't looked at, I believe, is you can come in and actually set a time when you want to look at rejects and alarms, live update. And this isn't letting me edit. There we go. When I drop out of live update, I can go back in and I can determine when I am going to look at information. So for example, we can go back to yesterday and we'll start and we'll set an end time that was also yesterday. So we're going to look at a small period of time. So let's just click this forward and we will view this information, apply these filters, and now we would be looking at historical data. We'll adjust this time here.
Yeah, so everyone looking, we're using simulated data here, so which is why there may not be data in this particular database. So can you also show me what it looks like, especially for monitoring activities, and especially if we're auditing or an auditor comes and wants to see what monitoring activities have taken place on any of my devices and what the results of those monitoring activities are? Can you just give me a brief demonstration or a preview of what that looks like?
Yeah, so I have some reports here that I've run from data that was collected earlier. So here's an example of a report that was run for the performance test. It's a 2-page document in this case. Through a production day, I would expect this to be longer, but we've captured that the PVR was done and passed. This particular test includes both my critical control point of the metal detector and the X-ray, and so we've got that captured. We've got another one here that is, this is performance test per device. Again, just another view. And then here's a report that shows rejects from the X-ray system that were collected over the past couple of days. And so that allows me to see that. It's fairly simple to create a report. We would come and for example, results. So you can see I have a list of several reports here. I can come in and we'll click on the X-ray. I give it a name. I choose the template that's going to be used, so on. I choose my filter criterion, where the area, the date. We're going to look at the last 4 days of the site in this particular one. The device type is going to be the X-ray detector, and we can automatically generate this. And we have selection as to what's going to happen with this report when it's automatically generated. We can send it to a printer, we can send it to a file, we can send it to an email, or we can do all of them together, depending on what the individual needs are. And then finally, we would view that report, and this is going to be similar to one that I'd already run, but this is how that comes out, and as has a sign off where if you need a hard copy, you can do that. We can save that file in any one of these formats. If we go back and look at how it can be automated, I'm probably jumping ahead a little bit, but the auto generation here, we can edit this and we can determine when we want this to automatically be generated. So it can be every night at midnight, or at the end of the last shift of the day if you run multiple shifts, or at the end of each shift. So you could have a report that documents specifically the activities of a shift, or at final evaluation, end of month, end of week. These are all the possibilities for automatic generation. And then, of course, for the email, you're putting in the email of the address of the person that you want it sent to. You're choosing, again, the type of file format that it will be in the email, which is separate from the type of file format that can be in the file name that's automatically generated and saved. There's same formats available, but each one could be different.
Well, next, that's really impressive. So, I mean, I think this is a good place where we can say that that was a good overview of what the software can do, and the only things that I can add to that is it's a powerful software that actually captures a whole lot of data happening on your control points, and within the software you've got a whole range of different options for creating reports, sending reports, and automating all of those processes, so that it's you set it up once, and then you're being fed the data whenever you need it, however you need it. So powerful features within the software. Thank you very much. I've got one last question. Sorry, this is just came to me. Is we get asked sometimes about how products can connect to other software solutions, like Historian, for example. This is not part of the reporting, but can you say just a few words on that before we wrap this part up, Vic?
Yeah. So ProdX has the option of being connected, becoming an OPC server, so that historians can function as an OPC client and connect directly to the database. Database becomes a server in that arrangement, and the historians now have access to most of the data that's in the database, and can actually get that now at the MES or the ERP level. So it's not uncommon for ProdX to reside in the OT network of a production facility, and yet some of the data that's being collected is desirable to be up at the higher level of the organization, at the ERP level, which is typically in an IT type of system. And so this allows the data to be retrieved from the database without the IT section actually having connection to the OT network, the equipment that's in that OT network.
Excellent, very interesting. Okay, thank you very much, Vic. If we move on now, we can then give everyone the opportunity to ask questions very soon. So thank you very much. Just for now, Vic, I'm going to now switch back over to presentation mode. So see you in a minute, Vic.
Okay.
Well, I guess that just leaves me to say, any questions? So the floor's open. Thank you very much for your time, and we look forward to some good questions. Thank you.
Here we go. Excellent. Thanks, guys. We have got lots of questions, actually. So let's get straight into it. So first one from Lara. What are the differences among BRCGS, SQF, and FSSC 22000? I think you'll be fit for that one, Rob.
Yeah, sure. The reality is there isn't much difference between them. They are each their own individual food safety management program. However, they are all under the GFSI umbrella. That being said, the GFSI basically sets a set of benchmarking criteria that any recognized food safety program underneath them must adhere to. Things like senior management commitment and, have validation programs, all those sort of things. They're very familiar all the way through each one of those standards. But being individual standards, some of them may have very specific requirements individually underneath them, their own standards. But what you can kind of view them as is globally recognized standards. So they kind of go cross borders. Like the FDA, they're kind of restricted here in the US borders as far as what they can enforce. The GFSI organizations are globally recognized programs and oftentimes are programs that are expected by retailers and certain customers.
Simon.
That'll help. Apologies. Question from Matil. Although all records are filled manually, signed or authenticated by digital systems and no falsification, in case of advocatory issue, will all records protect you? Is there any example that you experienced protecting you against advocatory or legal issues?
I can't say that we've experienced that directly. The fact is the information is being captured automatically and digitally, so it's not being transcribed or re-entered by a user. So in that level, it's secure. And if I think about the things that Rob said, it's the fact that you can show you're regularly doing these checks and tests and that you're maintaining your records for a period of time that is in line with your local regulations and laws.
Thanks, Vic. Next question from Abina. Can we then say manual documentation is generally unreliable? Is the industry completely going to move to digital modes? Is that a discussion that is ongoing with BRC, IFS, and the ISOs?
Yeah, I can start with the answer of that question, and that's no. You can't generally say that manual documentation is generally unreliable. It's how you carry it out. And yes, the industry is moving towards digitalization. If you're really, really good at your manual processes, because everyone's been doing them for a long, long time, there are a lot of companies that are good at them. It is still good enough, but moving forward, digital is going to take all of those manual processes, and it's going to be expected moving forward. Those processes are digitalized. And just then the last bit of that question, I think it's over to you, Rob.
Yeah, I don't think there is some push from the standard owners in that direction where, again, it's not necessarily a requirement per se, but there is kind of leaning towards expectations in that space. There's obviously significant added values in going to a digitized type system through efficiencies, through error, reduced errors, automatic entries, things of that nature. Like the ProdX situation, you basically go to the device and you type in your code to say, hey, I'm here and I'm doing this test. and it records everything. You're not having to do any other further real documentation of those processes. So the efficiencies and the efficiencies of retrieving that data as well is so beneficial that it makes sense that moving along in the future, we will see a more digitized.
Is it my screen that's lagging?
Yeah, I think so.
Yeah, so I've turned my webcam off so that it's a bit easier. Question from Michael: how is all the data or information entered during production runs? Did you get that? Sorry.
Yeah, we got that, but basically automatically, if it's attached to ProdX, if the device is attached to the software. But I don't know whether there's a more technical explanation of that, Vic.
Yeah, so the product inspection equipment is internally documenting the events that take place automatically, and when they're connected to a digital collection system such as ProdX, that information is transferred up immediately to be stored in the database. So the only thing that I can think of that has to be done manually is going to the device and entering the mode where the verification test would actually take place and acknowledging each time it passes, but that data automatically goes to the database electronically.
Okay.
It's worth mentioning there, Vic, as well. I know that Mettler has some auto testing capabilities with some of their systems as well. So we may move to a world where eventually people don't even interact with the devices as much. So it is a fast-moving advancement in technologies.
Yes, that's for sure.
Okay. Question from Laxman. Seems like the ProdX is specific to metal Toledo equipment such as X-ray metal detection. Can the software be customized for other equipment in-house?
I'm going to let you answer that one, Vic.
So there is some possibility for connecting third-party devices. I'm not sure that we've actually done it yet, but that capability is being developed. So I can't say for sure that it can happen right now, but I believe we're working in that direction.
What I can say is there is, through using OPC UA, check weighing data, weight data can be transferred from other third-party check weighers. But that's about as far as ProdX goes at the moment.
Okay. It's on similar lines, Khan is asking, can we connect the data to SAP data?
Yeah, so the OPC server functionality of ProdX allows an OPC client to collect that data and share it with historians, or SAP can get that. So SAP is typically at a ERP level or an MES level, and there are outside softwares that customers use that are able to take that data and further enhance the business model that company is using.
Okay. Okay. Thanks, Vic. Question from Jenny Flaw. Technically, in my workplace, we're documenting manually from validation, verification, and monitoring. We've done NSF audit scores 98%, but recently in a CFIA audit, we have a minor non-compliance. Would be better to stay in manual documentation or go digital?
Well, the thing about digital is you can't falsify the records. They contain within a date timestamp. So I don't know the nature of the non-compliance, but this would eliminate the question of, was it falsified? What was the source of the non-compliance? So the software that we use has the capability of, let's say, when somebody's supposed to do a performance test and it doesn't get done, well, we can have the software send an alert out that's saying it's overdue. So that can also add to the efficiency, where people that are working on the line don't need to be watching the clock and thinking, is it time to do the test? They can get a text alert or an email message that's alerting them that it's time. And then they can finish what they're doing and go do the test, which is then captured automatically. But we have customers that'll run that report at the end of every shift because they want to make sure that those tests are being done and that they have that information stored for their audits when they come due.
Okay, got you. Thanks, Vic. Question from Prasad. Can we do calibration check or validation of the counter? Does that make sense?
So I'm not exactly sure what the answer to that is going to be. The counter information is being generated by the device itself and transferring automatically. So at the end of the day, it would be a manual process to take the data that ProdX is collecting and verifying it with what's being displayed on the devices themselves, whether it be check weighers or such. I'm not sure, Prasad, if that answers your question or not.
If it's a validation of a counter, it needs to be a separate counter counting somewhere. You would then be using data from ProdX as a number. Then you could have data from the device as a number, and then data from a different device with a number at different places along the production line, and validate whether they're the same. But at some stage, you've got to trust the system, I think.
Yeah. Okay. Alicia is asking, my apologies, I likely missed this, but how does this work with multiple operators doing multiple data entry in manufacturing day? Does each operator need to log in when entering data?
So that would be, ProdX has named user licenses. So each named person would log into the software to do their work. Our product inspection devices also have users that would be logging in. ProdX is going to capture when somebody logs into a device and changes parameters. It's going to capture what the old parameter was, what the new parameter is, date, timestamp. So let's say in the situation of a weighing scale, somebody changes something and now the reject limits have been changed and they're rejecting more product than they did, or that type of thing. You get a date timestamp, so you can now search historically and see who logged in, who made the change, what the original values were, so that you can correct it. And you also know from that information how long the system has been running and let's say what we would call approved values. So you would want to perhaps re-inspect that product to re-verify once you've made sure the correct values are in place.
You're on mute again, Simon. Sorry.
Sorry, I'm aware we've gone 5 minutes over. Is everybody all right to carry on for a few minutes?
Yes.
Yeah.
Yes.
Okay. Laxman, is the ProdX software included with the machine when you buy a machine that detects glass or metal?
No, it is not. It's an additional purchase of the software licenses, and there are options available. So, you know, if you were glass or metal, so that's typically we're looking at metal detector or X-ray. So it would be an additional purchase where we would need to know what equipment it's going to be connected to, serial numbers and such, so that we can verify if there are any upgrades to the equipment required as well.
Okay. Francis, the food process floor is a multicultural environment. How does software cope with cultural differences in language used in recording?
I could speak to that mostly from the check weigher side, and perhaps Ian might be able to answer from the metal detector X-ray. Check weighers can be set up so that they have different languages being used, so it can be specific that way. I believe ProdX can also be set up that, but it would typically be one culture or another. So if you're locally speaking, let's say the Spanish language, most of your operators, you would have your systems set up to be this that language. It wouldn't be typical for there to be multiple languages being used in a facility. However, again, from the check weigher side, it is possible for each user to be set up with their own language that they use.
Okay, got it. Question from Nita. How can we test metal trays for metal contamination? Any system out there can help to detect metal?
There are metal detectors. I mean, we're getting into the realms of contamination detection here, but there are metal detectors out there that can detect metal contaminants where a product is in a foil container or a package or a pouch or a bag. It would be a case of that would need to be tested. I mean, at Metal Toledo, we've got in 3 places around the world, one in the US, one in Malaysia, and one in Barcelona in Spain. We have machines that a customer can send their products to them and ask us to do tests on to see whether we can test under certain circumstances. So that's it depends, possible maybe. Sorry, I can't get any closer than that. It's a bit difficult without actually having it in my hand and with a metal detector that could probably, maybe, possibly do it, and then proving the point.
Okay, no worries. Caitlin, for someone not able to do digital documentation, do you recommend time stamping your CCPs for employees rather than just an initial, they've done something on the form? I think the answer is overwhelmingly yes, isn't it?
Yeah, absolutely. You know, when you talk about records regarding food safety, that is an expectation that there's not only the when it occurred, who did the task, what task they performed, what the results were. Those are all pretty common things that are requirements from a records perspective.
Yeah. Gyro, what about creating your own software and using Google servers to store your data?
Well, so I think that's possible from many of the PI devices that we manufacture have the possibility of an OPC UA connection, and so through an OPC client, you may be able to get that information into Google servers. but it's still a client server. So it has to be one of those industry standards, I would say. So it might be possible, but I can't speak directly to how Google servers function.
Okay, thanks, Vic. Just a couple more questions. One from Darla. Any recommendations for making digital documentation legally acceptable and not able to be modified?
It is. When the data in ProdX, the way it's stored in the database, is it can only be modified by someone, as Vic pointed out earlier, someone who has access to the database within the company's network, and that's going to be only the system administrator. So the data coming out of that, I don't know whether we've actually been legally challenged on that, to be quite honest. But yeah, the recommendation is, yeah, get a software like ProdX, of course.
Okay. Abhishek, will a record in Excel sheet be considered as authentic in comparison to a handwritten one?
Well, you've got there 2 points of you've still got the points of human error there. So if you're taking a written one and you're transferring it into an Excel database, then you've got the written where you can have an error, and you've got the transferring of the data where you can also have an error. If you're using something like ProdX and you are exporting the data from ProdX to an Excel database, then it is better in comparison to a handwritten one. Yes.
Okay. And Laxman is just saying, thank you all for your wonderful presentation and patient answers. So that's a nice way to finish. So yeah, we're 12 minutes over, but yeah, thanks for getting through that. Lots of great information, and also the demonstration, the questions, etc., and lots of questions answered. So good job, everybody. Thank you very much.
My pleasure. Anytime.
Thank you. Always great. Always great.
Yeah. So to everybody, we'll be sending an email shortly with the recording slides and the certificate of attendance. Thanks to everybody for joining and engaging today in the webinar, and thanks to you guys again. And hope to see you all soon. Have a nice weekend.
Okay. Thanks.
Bye.
Bye-bye.